Okay, I gave you a handout on Friday in class, and the back side of the handout is a blank sheet. So maybe just turn that over and take the notes on the blank sheet. That way you have everything all together. So I would like for you to probably pause the video and write this down, and then I'm going to go back and fill in the pieces. So this is what's known as our quadratic given in standard form. Each term has its own name. The first term is called your quadratic term. This is my quadratic term, and A is called the lead coefficient. The lead coefficient. A cannot equal 0 because if A equals 0, then it's no longer a quadratic, then it's simply a linear equation. So term Bx is called the linear term. And then C is called the constant. So notice that the degree on the linear term is 2. The degree on the quadratic term is 2. The degree on the linear term is 1. And the degree on the constant would be 0. So this is your quadratic in standard form. And now let's look at multiplying binomials. And I'm just going to use example number 1, given on the pizzazz with the stick of gum. So I think that's the heading, the riddle heading. So here I have x plus 3 times x plus 5. And I will illustrate the method that's known as FOIL. But FOIL only works when you have a binomial times a binomial. So the F in FOIL stands for first. So that means that I'm taking the product of the first term in each binomial. So that would be x squared. And the O stands for outer. So I'm taking the product between the outer terms. So the first term here and the last term in the second. So the x and the 5. So that's plus 5x. And then the I stands for inner. So that means I'm taking the product of the two terms that are right beside each other, the two inside terms. So that's 3x. And then finally, the L stands for last. The last term in each, the 3 and the 5. So that's plus 15. So the last product would be 15. And then you're simply adding all of these up. So where you're combining like terms. So the end result product would be x squared plus 8x plus 15. This only works when you have a binomial times a binomial. So I don't want you to fall in the trap of trying to make everything fit with the FOIL acronym. And then I would like to explain this one other way. This is really just a distributive property. So the first thing, I'll color code this. The first step is to multiply the second binomial by the red x, and that's just distributing that through. And then next you can think of it as the red 3. Now it's red 3's turn to multiply in or distribute into the x plus 5 binomial. So that gives me 3x plus 15. Then you combine like terms and you end up in exactly the same place. This is what's happening. I don't want you to do your work like this. I don't want you to show your work in this manner, but I do want you to understand that you're just simply distributing one term at a time into the next binomial or the next polynomial. So the last example I would like to do on the video is number 13, where you have a binomial and you're multiplying it into a trinomial. So I just want to show you that the acronym FOIL no longer works because now I have 2 terms and 3 terms. So the way that I would like for you to think about this, my first term will be n cubed, my second term will be 5n squared, and then my third term will be negative 3n. And then I distribute the 2, so I have plus 2n squared plus 10n and then minus 6. And then you analyze to combine like terms. So I have squared and squared. So let me just copy the n cubed down. And then the squared term has a coefficient of 7, so that's 7n squared. And to the first power, that's going to have a coefficient of -7. And then finally the constant of -6. So that's your final end result product. And we're really not going to give this a special name. It would be a cubic, we're just going to call this a cubic polynomial. We have 4 terms. The highest power is 3. We'll go back to the vocabulary just a little bit.